In section 9.5, we'll again work on solving systems of equations. This time we'll look at non-linear systems of equations. Remember, there are two different methods we can use to solve systems of equations. We learned two different methods. They are substitution and elimination. Now, as in the past, sometimes substitution works better, sometimes elimination works better. It just depends on how the problem is set up from the beginning. So let's look at an example. If you look at this first example, notice we have two equations and two variables. Well, look at that second equation. If we start out with this second equation, it's really easy to get one of the two letters by itself, which means we should probably try substitution. Well, if we try substitution on that second equation, starting with that one, we will start with the x minus y equals 0. Well, what letter is easiest to get by itself? Well, the x is easiest to get by itself by adding y to both sides. Then we just come up with the replacement that x equals y. What does that mean? Well, that means that I can replace any x's with y in that second equation. So let's start with our second equation, which is actually the first equation, the only equation we haven't used, which is the x squared plus y equals 2. And let's use our substitution from our first step, that x equals y, and plug it in. So let's replace our x here with x equals y. Well, then that means that that x will turn into a y. Well, notice when we do that, the result looks like a quadratic equation. Well, how do we solve a quadratic equation? Well, we can't until the equation equals 0. So the first thing that we had to do was get the 2 to the other side of the equation so that it equals 0. So we subtract 2 from both sides of the equation. Well, now we are all set because now we have a quadratic equation that is now equal to 0. So the question is, what do we do now? Well, there's two options. We can, one, factor, or we can, two, use the quadratic formula. The hope is that it factors, though, because factoring is much quicker than using the quadratic formula, but the quadratic formula will work in any situation. So let's factor. And indeed, this does factor. You'd be asking for what two factors of -2 add up to the coefficient in the middle, which is a hidden +1. So what two factors of -2 add up to +1? Well, that's a +2 and a -1. So you can see that it factors as y plus 2 and y minus 1. The question is, what do you do once it's factored and equal to 0? Well, now then we set each piece equal to 0 and solve them as two smaller equations. So if we look at the first one and we solve that first factor set equal to 0, we get that y equals -2. Well, be careful, that's only part of that solution. If y equals -2, what's the corresponding x value that goes with it? Because these should be points of intersections for these graphs. So you got to replace the y equals -2 into your first equation. Well, if you replace the y equals -2 in your first equation, you'll also get that x equals -2, which makes sense because remember our first equation says that x equals y, and we got y is equal to -2, so x should be equal to -2. So that is our first solution, our first point where these two graphs intersect is -2, -2, because we've got a -2 for y and a -2 for x. But when we factored, we got two solutions. We also got that y minus 1 needs to be set equal to 0. So to solve that, you'll add 1 to both sides. Again, you have to plug that back into the first equation, which gives you that x also equals 1, which makes sense because, again, x and y are equal. So we get a second point, which is positive 1, positive 1. So we get two solutions to these systems of equations. Well, notice that kind of makes sense. If you look at the original two equations, one of them appears to be a parabola, the other appears to be a line. So what this is saying is the parabola and the line are intersecting at not one point, but two different points.